All right, so now we're going to take a look at how these rational functions that we're talking about operate in Algebra 2. So here's some key vocabulary. A rational expression, again, is a ratio or fraction of two mathematical expressions. You saw in the Algebra 1 review examples that they were simple expressions of integer with variables. But in Algebra 2, we really focus on the idea of polynomials being in the expression, and that's the difference between Algebra 2 and Algebra 1. So then the next thing is, well, what kind of things do we need to worry about with rational expressions? We don't have to worry about this in Algebra 1 very often, though sometimes it comes up. But in Algebra 2, the idea of the greatest common factor is essential to the entire chapter. So what is a greatest common factor? Surprisingly enough, it's the largest term that divides evenly into all other terms. So if you think about what I'm saying, it's basically the largest multiplication fact that they both share. And that's why I focused in the Algebra 1 problems of think about multiplication facts. So if you look at this problem right here, if I look at these two numbers, the greatest common factor is the greatest multiplication fact they share. This is 12 times 2, and this is 12 times 3. So what is the GCF? The GCF is the greatest number that they share together, okay? And so the greatest common factor for this would be 12. Now, some students will have trouble finding that directly because, of course, not everybody knows the greatest number that, for instance, like 108 and 112 share, right? So how do you do that if you don't know it off the top of your head? What you actually do is you make a prime factor tree, as you've seen done many times in this class. And what you do is you make a prime factor tree, but you're not taking a square root, you're using it to find the greatest common factor, which is kind of interesting, and I'll show you that. So this one would be this. Now we don't circle anything or write any roots because we're not doing that skill here, but we are using the same concept of a prime factor tree to determine the greatest common factor. So how do we determine the greatest common factor? The greatest common factor would be everything that they share in common. For instance, they share a 2. Okay, they share another 2. They do not share this 2 and this 3, but they share this 3. So we saw earlier that the greatest common factor was 12. And so watch how this works. The greatest common factor would be these numbers that are shared. It would be the common 2 times the other common 2 times the common 3, which would be 2 times 2 times 3, which would again be 12. So that's how you can find it if you don't know it off the top of your head. This idea is extremely important when I look at a polynomial expression and try to find its greatest common factor. Because the greatest common factor, again, is going to come from the factorization of these two expressions, which for integers is a prime factor tree. But for an expression like this, it's the same old factoring that we've been doing for 2 or 3 units now. We start here, we move this way, we ask ourselves what factors of 18 will subtract a 3. So that would be 3 times 6, right? And so we put our factors down right here. We put a 3 and a 6, and then we ask ourselves, well, how would we subtract these numbers to get a positive 3? We would need to make this one negative and this one positive, because negative 3 and 6 makes positive 3, and then we have our x's, okay? Now, when we look at the next expression, we're going to factor it the exact same way, but we have different numbers. But the hope is that there'll be something in common, right? Greatest common factor. So 12, again, we're going to start factoring it by going this direction. The factors that are going to subtract to 4 would be 2 times 6. So I'm going to put my 2 here and my 6 here. And then I'm going to say, okay, this one's also subtraction, and I want the 4 to be the positive outcome. So I have a negative here and a positive there. And then I have an x to make x squared. And so then I look at it, and it becomes pretty obvious that my common term is x plus 6. And that is, again, the greatest common factor. I mean, try to listen to the name there. The greatest common factor would simply be what they share, which would be x plus 6. Okay, this concept is pretty routine, and it makes a lot of sense in Algebra 2 as well as in elementary school. But then it gets confused sometimes with the least common denominator, which is also a key understanding in this unit. And you'll see a lot of relation to what we learned in elementary school to what we're learning in high school. In fact, that's how I teach this entire lesson. So let's take a look at what a least common denominator is. Sometimes the least common denominator is called a least common multiple, by the way. And the least common denominator is the smallest term that all other denominators will divide evenly into. That's a pretty difficult concept to understand. So it's the smallest number that these denominators here will divide evenly into. And again, we're going to start with the factor tree, okay? So we're going to take this factor tree and we're going to examine it along with this factor tree. And the way you figure this out, okay, it's a similar thing, okay? So it starts off, and this is why people get this confused, the least common denominator includes the GCF. They're not the same, right? So let's take a look at the analysis of how we figure this out. What you're going to do is you're going to start with the same idea of we're going to have our common numbers, okay? So we have our common numbers, but then we also are going to multiply by the non-common numbers, and that will get us our least common denominator. So let's see how that works out, okay? So our LCD is going to be the common numbers that are shared, 2 times 2 times 3, but then also the uncommon numbers, 2 times 3, and that product will give us the least common denominator. So this again was 12, right? The common ones are 12, the uncommon ones are 6, and so our LCD will come out to 72. Now you may say, whoa, that's a huge number. I purposely picked like the worst problem you could think of in elementary school, right? So what is 72? Keep in mind that 72 is divisible by 24, right? Because if you divide 72 by 24, you're going to get 3. And then also 36 is also, 72 is also divisible by 36, right? So 72 is also divisible by 36 because it'll go in there twice. And that's what the least common denominator is. It is the smallest number that the two denominators you see will evenly divide into, producing an integer answer. I know that's complicated, but that explains why when you learn this in elementary school, it was really difficult to do. It's really an algebra process. I mean, you have to think up an unknown number that these two things will go into, and you have to make sure it's the smallest number possible. So the question now is, okay, what do I do with that, right? Like, what do I do with that information? It actually makes the algebra pretty straightforward, believe it or not, okay? So the algebra, notice I have the exact same two expressions here. So this one that I had above, that is, I have the exact same expressions here. So this one, again, will factor into x minus 3x plus 6. So x minus 3 and then x plus 6. And this one will factor into, again, the same thing we had a second ago. X plus 6 was here, and then over here we had x minus 2. Again, 3 times 6 is 18, 6 minus 3 is positive 3, 2 times 6 is 12, and then 6 minus 2 is 4. So what is our least common denominator for this? It's actually a little simpler in algebra because there's less going on. You take your common one, right? Here's your common term, and that will be your common one that you have. And then you take the other uncommon ones, and they also have to be in the list. Now, that being said, those two right there are just simply, think of them as like basically the leftovers. Now, in algebra, you're not going to FOIL this together. We did that in the polynomial chapter. It's a lot of extra work, and actually you use this thing right here to actually cancel things out. So unlike in elementary school where you had to find the number and then maybe show that it divides evenly, in Algebra 2, you just stop here, and then you use this to do some simplification or reducing of the expression that you're given.